Good day, students. In this clip, we're going to be going over how to use factorial notation. So, right on the title of this lesson, uh, finding the finding the factorial. Okay, finding the factorial. All right, so we're going to apply the definition that I just went over to the following examples in computing the factorials of the given numbers. So, and then I'm also going to show you how to use a calculator to compute the factorial, okay? Number one, let's, so examples, evaluate the following. Let's say we had 5 factorial, okay? That's not 5 exclamation mark, that's 5 factorial in math. What does that mean? That means you're going to count from 5 to 1 and then multiply the products of all the numbers, alright? So counting down from 5, we have 5, 4, 3, 2, 1. So 5 times 4 times 3 times 2 times 1 is what 5 factorial is. Okay, if we multiply them, 5 times 4 is 20. 20 times 6 is 120. Alright, so that's 5 factorial. If you wanted to do it with your calculator, there are two ways you can do that. If you want to do 5 factorial, first of all, enter the number 5. And then under the math menu, you press math, and then you go over to the probability tab. Under the probability tab, you have a whole bunch of probability operations here, or functions here. So let's select function 4, which is clearly factorial. So 5 factorial, enter 120. Another way you can do this is you can go to catalog. Second function 0 gives you access to everything in the catalog. You scroll up continuously and then you end up with the factorial symbol right here. Bam, 5 factorial 120. Okay? Or you want to do it the long way, 5 times 4 times 3 times 2. If you have energy to waste, you can do it this way. Alright, let's take a look at another example. Number 2. What is 4 factorial? 4 factorial is what? It's 4 times 3 times 2 times 1, right? 4 times 3 is 12 times 2, 24. Alright, number 3. What is 0 factorial? Now this is one unique property of the factorial notation. One of the very few properties that acts on 0 to actually to produce something other than 0. So 0 factorial is simply 1. Okay, don't forget. Number 4, what if we have a ratio or a quotient of 2 factorials? What if we have 5 factorial divided by 3 factorial? Now in this problem, I'm going to show you two ways of doing it. The long method and the short method. Hopefully you guys will see the smartness or why it's much more effective to use the short method. So I want to do this using method 1. Let me just call this M1, method 1. For method 1, I'm just going to break both of them down blindly. Okay, I'm going to go 5 times 4 times 3 times 2 times 1 divided by, do that again, times 1 divided by, what is 3 factorial? 3 factorial is simply 3 times 2 times 1. You can see some cancellation happening here. 3 goes here 1, 3 goes here 1, 2 goes here 1, 2 goes here 1, and these ones cancel out. The final answer is 5 times 4, which is 20. Okay? Now you notice how these two match? 3 to 1 and 3 to 1. What are these? Well, let me show you another way of doing this. Okay, method 2. What if I broke down 5 and stopped at 3 factorial? So what if I said 5, let's rewrite the problem, 5 factorial over 3 factorial. What if I said I go to 5 times 4 times 3 factorial stop? What if I choose to stop at 3 factorial? And then the denominator, I decided to just hold it like that. You see what happens? Instead of writing these 2 factorials down and then canceling them a million times, I can leave them as factorials and just cancel them with 1 fell swoop. 1, 1. The answer is simply going to be 20. See that? So that's the idea about doing ratios of factorials. Alright, let's try a slightly more complicated one. Number 5. What if we wanted to do 10 factorial divided by 7 factorial, 2 factorial? Okay? Now I'm going to take 10 and break it down to one of these two. I have to break down one and keep one. I like to break down the smaller problem and keep the bigger problem. Alright, this is a bigger problem for me down here. So I'm going to break it down to the bigger number so I can cancel that out. And instead of having to break down 7, I just have to break down 2. Okay? So this is going to become 10 times 9 times 8 times 7 factorial. Is much shorter than going all the way down to 2, right? So I'm going to keep 7 intact in the denominator. Keep this 7 factorial as a package. And then 2 times 1. Okay? The 7 factorials cancel out. And we can reduce here, or we can multiply across and then reduce. Let's just reduce here. 2 goes here 1, 2 goes here 4. 40 times 9 is 360, so your answer here is 360. Okay? Let's verify our answers with a calculator. We're going to go 10 factorial. 10 factorial divided by, now when you have multiple terms in the denominator, you have to group them with a parenthesis or else it will get separated, okay? 7 factorial, 2 factorial. And the answer is 360. See how I group the denominator using a parenthesis? That's how you do it. If you don't, it's going to give you a different answer, okay? Let's say I didn't group it. Let's say I did it like this. Delete that. Delete that. You see how it's giving me something else? So please group your denominators if you want to get the right answer, okay? Alright, cool. Now let's move on to one more example, and then we can go ahead and start on the first part of the classwork. What if we had 9 factorial divided by, I don't like that division bar. 9 factorial divided by 6 factorial, 5 factorial. Okay? Now, which one should I break? Which one should I keep? The 5 or the 6? They're pretty close, right? If they're the same, it doesn't matter, but this is bigger, so I like to keep the bigger one intact because there's a problem, and then break the smaller one, okay? So that bigger problem can be canceled out. So I'm going to go 9 times 8 times 7 times 6 factorial. Stop. Let me put that in blue. Stop at 6 factorial. And then divide that by 6 factorial stays intact, and then 5 gets broken down. Okay, you have to break these 5 factorial down. 5 times 4 times 3 times 2 times 1. The 6 factorials cancel out. This cancels out with that. 1, 1. Let's see, what else cancels here? 4 and 2 cancel out with the 8, because 4 times 2 is 8. Let's multiply out so that we don't get confused. Okay, 9 times 7 is 63 divided by 15. Alright, 3 goes into both of them, so I can reduce by 3. If I divide both of them by 3, I'm going to have 21 over 5. Okay? 21 over 5, and there goes your final answer, 21 over 5. So that's like 4.2 basically. Alright, so let's check our answer with a calculator. Left side, 9 factorial divided by 6 factorial 5 factorial. 4.2, right? 21 divided by 5 is 4.2. So they have their answers correct. Okay? Alright, let's go ahead and start on the first part of today's classwork. Alright, welcome back, students. Now we're going to learn how to apply the combination formula that we just went over. So write down the title of this lesson, Applying the combination formula. Combination formula. Okay? Alright. We remember what the combination formula is, right? The different renditions for it. Let me just put it down here again just for quick reference. So NCR, which is the same thing as C, N comma R, which can also be written as stretched parenthesis N R. All these three things simply means N factorial divided by N minus R factorial, R factorial. This R factorial basically means that there is no order in our arrangement of R elements that we're selecting out of N objects. Okay? So this means no order. Alright, let's try out some examples. Evaluate the following. Evaluate the following. Alright, let's try out number 1. What is 5 choose 3? Order not important. What is this? So 5C3, remember the bigger number, the first one is always N and the small number is R. If I apply to this formula right here, it's going to be 5 factorial divided by 5 minus 3 factorial, 3 factorial. So that becomes 5 factorial over 2 factorial, 3 factorial. Now I'm going to break down the 5 to the bigger of the two, which is 3. So this is going to become 5 times 4 times 3 factorial stuff divided by, we break down 2 factorial into 2 times 1, and then 3 factorial stays just the way it is, okay? Alright, the 3 factorials cancel out. 5 times 4 is 20. I'm going to have 20 over 2, which is just 10. So final answer is 10. Okay, so we can do this in a calculator. I don't know if you remember that there was an option in the math menu that said NCR. So what we're going to do is the first number you want to enter is 5. You type in 5, and then you go to math, probability 3, meaning number 3 is a combination, okay? Enter, and then the second number 3, and final answer is 10. Okay? This works perfectly for really big numbers that you don't want to spend too much time working on. Alright, let's take a look at another example. Number 2. What is 6 choose 4? What is this? Let me rewrite it again. My parentheses are not symmetric. What is 6 choose 4? Okay? So this one is the same thing as, you can write this as 6C4 is also the same thing as C64, same thing. Alright, this is N and this is R. All these three things mean the same thing. So if I apply the combination formula, it's going to be 6 factorial, which is N factorial divided by N minus R is 6 minus 4. According to this formula right here, factorial 4 factorial. Okay? Now let's simplify this a little bit. We have 6 factorial divided by 2 factorial, 4 factorial. So break down the 6 down to the bigger one, which is 4, and break down the other one. So 6 times 5 times 4 factorial stuff divided by, break down the 2 factorial, 2 times 1, and leave the 4 factorial intact. These two cancel out. So you're going to have 30 over 2. 30 over 2, which is simply 15. So your final answer here is 15. Okay? So let's check it in a calculator just to see if we're correct. So I'm going to be lazy and pull up the other one. Change this to a 2. And, ooh, snap. And insert a 1 in front of the 5. No, it's supposed to be 6, huh? What am I doing? 6, choose 4. Bam. Answer is 15. So we are correct. Alright, let's do the last example. And then we're going to try out some classwork problems. Hopefully you will do well in those. So what is C4, 0? What is this? This is the same thing as stretch parenthesis 4, 0. It's also the same thing as 4C0. Okay? If I apply the combination formula here, this is going to be N and this is R, so it's 4 factorial. divided by 4 minus 0 factorial, which is just 4 factorial, times r factorial, which is 0 factorial. Remember, 0 factorial is 1, right? So we're just going to have 4 factorial, leave it whole, over 4 factorial times 1. 4 factorial over 4 factorial. These are identical, so this goes here 1, this goes here 1. Your final answer is 1. Okay? So let's check if our answer is correct. We're doing, let me bring this back up. We're choosing out of 4 is 0. Final answer is 1. Okay? So there goes your result. Thanks for paying attention to this clip. Remember, it's uploaded on YouTube for your viewing pleasure.